You can begin. You can start.
Should I start?
Yeah, yes, you can. Yes.
Good afternoon to one. I welcome you all to my presentation that is automation in pulp and paper industry. I would like to introduce my batchmates. That is me, I'm Chinna Bengeri, and Swati, Vijay, and Ranjan. Let us move into our first slide. Now, next slide.
Okay.
So, the today's contents which I'm going to discuss are introduction, plant areas, processing areas, manufacturing areas, DCCS application, energy issues, and conclusion. Next slide. There are two distinct processes in which the manufacturing process takes place. One is the processing of pulp and the manufacturing of paper. Usually, processing of pulp is done by using wood, that is, paper is prepared by using wood. The cellulose fibers are being freed from the lignin, which are where they both are cemented together. It can be done through mechanical processes or chemical processes. Chemically, the solution is used to free the to divide the fibers from lignin, uh, and actually they use two processes. I mean, uh, two machines are used, different types of machines. One is 4D linear machine, 3 linear machine, and cylinder machine. These are the two machines which are used in automation industries. Usually, in our pulp stock is prepared by formation of for the formation of paper, either by beating or for refining. Refining is done through chemical processes which need to be continuous. Next slide. When we go into the plant areas, overall processes, it has three different plant areas. One is the processing area, where the extending from wood yard, that is stock accumulation is done in the processing area. In the manufacturing area, the paper web is produced, and in plant area, the electrical power is supplied. Sorry, ma'am.
Yeah, continue.
In the plant areas, the required power is supplied through the plant areas to processing area and the manufacturing area. The next part of the slides will be continued by Swati.
Okay.
Next one.
Swati, you can unmute yourself and you can continue the presentation. Again, I will be controlling the slides.
Yes.
You can turn on the video. Huh? You can
Yes.
turn on your video and continue.
Shall I start, ma'am?
Just a minute. You have turned on your video. Okay.
Yes, ma'am.
Now I will put it to presentation mode. I think she has left at which
Yes,
slide? This slide, no? Processing area.
yes, ma'am. Processing area.
Okay, you can continue from here. Let me share the
Yes.
slides with you. Uh, slides are visible?
No, ma'am.
Just a minute. Okay, now slides are visible.
No, ma'am.
Slides are not visible now.
Ah, yes, ma'am. Now they are visible.
Okay, now you can start your presentation.
Yes,
Shall I
ma'am.
move on to the
As she said,
next slide, or you'll continue from this slide only?
I'll continue from this slide.
Okay.
As Chinna said, processing area is a large part of the production of pulp and paper industry. Processing area has continuous sequence of operation It starts from wood yard production and ends at accumulation of stock. Processing area has a large number of batch operation which are continued for certain length of time. Each sub-process is independent of other batch. In next slide, we can see the block diagram of processing area. Next slide.
Okay.
As we can see, the processing area start from wood art. Here, the raw materials are collected. Raw materials include wood art, sawdust, and other small pieces. Uh, they are raw materials. Wood art and sawdust they are used for paper production, and other small pieces are used heated. Steam is produced. That steam is used to power the machines and to run the turbines, which in order to generate electricity. Then the wood art pieces they are grinded. They are grinded or they are mechanically heated or chemically heated. They are grinded in sense they are put into digesters in which the materials are heated. Mechanical pulp production in this method, the wood art is mechanically grounded, the mechanically turned into fine pieces. In chemical pulp production, the wood pieces are heated in the presence of chemical liquid called uh, hydrogen sulfide, sodium sulfate liquid. Then the bleaching is necessary to obtain the opacity, strength, and ink receptivity. GMP implies ground mechanical pulp, which is similar to mechanical pulp production. TMP implies thermochemical pulp, in which the pulp is heated before it is sent to the refiner. CTMP is a chemical method of obtaining pulp. Here, each sub-processes are end at stuff treatment. The in digesters there will be pulp heated and it is converted into black liquid where the uh, where it has maximum amount of water. The water is evaporated and main content is to be kept in the tank. The cellulose is the main content from which the paper is manufactured, or pulp is manufactured, from which the paper is manufactured. Then the stuff is sent to the manufacturing area. The next part will be continued by Vijay.
Okay. Now Vijay can turn on his audio and video and continue. Vijay is here. You can turn off your video, Swati.
Yes.
Vijay is here in the meeting. I don't find him. Vijay? Vijay is here. Any of your batchmates can reply. Why Vijay is not here?
Having some network problem, ma'am.
Okay.
Since he's in a village.
Okay. Somebody has to continue on his behalf because the marks will be allotted for the batch. With whether Ranjan is ready to continue. Ranjan, will you continue?
Ma'am, I will continue on a ninth slide onwards.
No, all of you have prepared it together, no? At least you read
No,
out
ma'am,
those slides, huh?
Okay.
Huh? Because that continuity must be there. It is not that you don't understand the middle portion of that one and then directly understand only a part of that one. That is not the teamwork.
Okay.
Hmm? So let me, you can turn on your video, Ranjan, and I'll share the screen. You have to continue from the uh, point where Swati has left. You have to turn on your video also. Have you turned on your video?
Yes, ma'am.
Okay. Slides are visible?
Yes, ma'am.
Okay. So you can, yeah, you can continue from next slide.
Good evening to one and all. Let us discuss about manufacturing area. The main difference between manufacturing and processing area are a large number of variables, speed drivers, controlled speed of which determined operating speed, wet tensions, slitter, windows, and rewinders. Next slide. Let us move to the block diagram of plant area and manufacturing area. Plant paper manufacturing mainly takes place initially takes three materials such as pulp, waste of tree, and as well as the bamboo tree. The chips of a pulp is uh, passed through the beaters in which it consists of brushes, and it can be stored at the one chamber place where 99.5% of water is added, and rest of will be added by the pulp, and it is stored in one of the containers for several days where the pulp is settled down, and water is become upward level, and it can be extracted out such that the liquid pulp is rolled over the pressure rollers and suctions, and it is dried for it is dried for at the several temperatures, and also it is passes through the cylindrical rollers to obtain the paper. Next slide. Let us move to the DCS applications in pulp and paper plant industries. The DCS illustrates the top-down hierarchical strategies with the different control functions at different levels. In addition to this, the system units are distributed throughout the process. Let us move to the paper automation, in which it consists of three levels: process control level, man-machine interface level, and plant management level. The sub-process is interconnected to the at least one of the units in the process control area, or it is interconnected to the several sub processes where the sub processes acts individually, and at the several uh, in a certain parameters required to them. In a man-made man-machine interface level, the sub-processes are interconnected and branched towards in an entire single control loop. It is controlled by the man. The data transformation is takes place between the sub processes and the control units by the via buses or links. It can be taken as a safety purpose also. uh, Next slide. Okay. Let us we are seeing the sub processes as well as the three parts of the main processes, that is process control plant, as well as man machine interface, and also plant management. At the topmost level, it is a plant management where the single computer controls the entire plant areas. Next. uh, by seeing all this, it is stated that the paper manufacturing is eco-friendly and environment no harm for environment, and also it is taken as safety purpose interlocking and strategies, and for improving the control loops, it can be implement the single loop integrity can be implemented, and among Asia, Indonesia is the largest producing country of paper.
Hello.
Yes, ma'am.
Okay, completed?
Yes, ma'am.
Okay, good. Okay, I appreciate all the three. The slides are very good. The organization of the slide is very good. Whoever, I think Vijay, except Vijay, all of you have presented in a very convincing manner. So I appreciate your efforts. and I'm going to allot the marks accordingly for the assignment. The next batch is ready. PB2, batch PB2. Somebody from batch PB2, can you tell me what will be the order
Yes,
of the
ma'am.
presentation? Who is going to present first, Pawan?
Yes, ma'am. Ma'am.
ನೀವೇ ಪ್ರೆಸೆಂಟ್ ಮಾಡ್ತೀರಿ ಫಸ್ಟ್ ಸ್ಲೈಡ್ಸ್ನ ಹಾಕ್ಲಿ.
Madam.
Okay, let
Okay,
me
ma'am.
let me adjust the slides first. Okay. Okay, so now I'm going to share the screen for which consists of slides made by batch 2. Pawan will start with the presentation. Pawan, you have to turn on your video. Then I will share the screen so that you can start the presentation. Turn on your video also.
Okay.
Okay. Slides are visible. Can you
Yes,
see?
ma'am.
Can you see the slides?
Yes, ma'am.
Ah,
Good afternoon, everyone.
okay.
I am Pawan. Now I discuss about automation trends in cement plant. Ma'am, next slide, ma'am. Contents are automation trends in cement plants and DCS application in cement plants, raw mill control and cement kiln control. Next slide. Automation trends in cement plants introduction. The cement industry occupies the important place in both the building and industry and building industrial base of country. India is the second largest cement producers in the world. In modern days, infrastructure plays a virtual role. Next slide. Computer-based automation is the best technique for the above function. DCS faster, reliable, has many helpful features to its credit. It enables to you manage the process to complete the system. Next slide. The industrial background. The history of cement industry. India dates back to 1889 when the Kolkata-based company started manufacturing the cement following Julius. In 1914, the cement units were established, one of each Porbandar and Bundi. Next slide, ma'am. In the year of 1924, the three cases into extends the cement factories. India is the installed capacity of 5.6 lakh tons. For popularizing the case of indigenous cement is the Concrete Associate of India was formed in the year 1927. Next slide. The process manufacturing cement plant. The major operation of involved in the manufacturing process cement are raw mix raw mixes preparation, example crushing and grinding and or washing of raw materials, producing the requirement components, preparation of clinker production by the burning and raw mix kilner and temperature, cement production by grinding clinker with a small amount of gypsum, storage, packaging and dispatch the cement. Process control in the cement industry has involved in steps during the last 50 years. All sensing the process variables manipulation of actuator was performed many by the operator at local basis. With the development of sensor and controller, indicator and recorders and remotely operated by actuator, the next stage in the evaluation was centralized control of all instrument instruments, and motor control stations for various process areas. The first central control plant in the cement industry went into the operation up in 1956. All new plants are controlled since 1960 as adopted by central control concept. Next slide. Ma'am, next slide. Ma'am,
Visible? Visible? Continue.
ma'am, next
Ah,
slide, ma'am.
wet process you are explained. Next,
Hello?
tell me. Tell me, Pawan.
No, ma'am. No, ma'am.
Next, can you hear me?
See the
Which slide you want? Previous or the next one?
ma'am, explain on my wet process, ma'am.
Shall I go to the next slide?
The wet process. No, ma'am.
Back.
Wet process, ma'am.
Is
No,
it
wait,
okay?
we don't.
Okay.
No, ma'am. Ma'am. The
Start.
flowchart is the wet process mixing the raw materials in wash with 35 to 50% water and material exciting the material exciting in mill are called sulfury have flow rate 36 size of kiln needed manufacturing cement is bigger. Ma'am, next slide, ma'am. The raw material can be mixed easily, so better homogeneous mixed by the obtained fuel consumption of 35 kg of coal for ton of cement produced. Cost of product is high and cost of establishment is less. This is the wet process. And dry process mixing the raw materials and dry state blenders. The dry material exciting will be scaled and feed size is kiln node manufacturing cement is smaller, cost product is less, and capital is cost is high due to the blenders. Next slide, ma'am. The process computer control cement in plants. The objectives of computer control has been improvement plant operation informed more economical raw mixes and increases the production high fuel efficiency and emphasis shifted by the dynamic composition blending and stabilization kiln cooler operation.
Okay, how many
Next slide,
slides you have? Who?
ma'am, and ma'am, the last one.
Okay.
Computer control as since the blending is the programmable, the PLC for sequence control, data logger for plant monitoring, advanced development, advanced, development PCS ability handle both digital and analog input outputs, remote intelligence, load capacity. Next slide.
Okay, who is going to present next?
So, ma'am.
Okay, Soumya, you can turn off your video, Pawan. Soumya can turn on her video. Soumya,
Yes, ma'am.
Shirur. Yeah.
Yes, ma'am. I turned on.
Okay. You have to continue from this slide.
Yes, ma'am.
Can you continue?
Yes, ma'am.
Okay.
Good afternoon, everybody. Now I'm going to explain you about DCSA's application in cement plants. As the name itself suggests, distributed control system is a control system in which the control is distributed throughout the system. DCCS are used to control industrial processes and increase their safety,
cost effectiveness, and reliability. DCCS are commonly used in several processes, including cement plants, paper and pulp plants, agriculture, chemical plants, and so on. In a three typical maximum tolerable period of disruption, approximate number of inputs and outputs are as follows. Digital inputs for interlocking and sequential control is 1000. Digital outputs for interlocking and sequential control is 360. Digital inputs for status monitoring is 460, and analog inputs for measurements is 230, and analog input outputs for control is 140. And various DCCS configuration have been used in cement plant automation involving PLCs, multi-loop controllers, remote terminal units, and process computers. Next slide, ma'am.
Visible?
The figure that is, yes, ma'am.
Start.
The figure that is PC based DCCS configuration for cement plant shows a DCCS for a large cement plant implementation using programmable controllers by ASEA. ASEA is a Swedish industrial company. As shown in the figure, the control system is divided into various autonomous control blocks, where each of which is assigned to a sub-process. In this, next slide, ma'am. In this, each control block has its own control desk, including raw mill, cement grinding, and clean plants. The control desk for crushing and packing plants and usually decentralized, that is, they are installed near their respective sub-processes. Various sub-processes are involved in cement manufacturing like preheating, grinding, raw mill, cement clean. And in that, raw mill and cement clean are the most important from the control point of view. And the next part will be continued by Soumya.
Okay, Soumya can take over. Soumya Dupad, you can turn off your video. Soumya Dupad, turn on your video and you can continue with the next slide.
Yes, ma'am. Good.
You can turn on your video. Okay.
Yes, ma'am. Good afternoon, everyone. My topic is raw mill control. Raw mill control is together used with cement kiln control. Here the parameters are controlled and monitored within the limits, and 60% of the energy is used for raw material and clinkers. For grinding, control of mill is very important, which is used to achieve economical plant operation. Here we have to maintain the moisture content. If the moisture content varies greatly, it is used for energy utilization and good dedusting. And uniform quality of cement and uniform composition is also required. After doing this all, we subject the raw material to X-ray analysis. When we pass through X-ray analysis, we find the chemical constituents such as calcium, silicon, aluminum, iron, and magnesium. And after X-ray analysis, the data is aided by microcomputer for further analysis. And after further analysis, we give it to microprocessor, where microprocessor based system is used to improve the quality of homogeneous raw material and lower the production cost. Next slide, ma'am. For automating grinding mill, here some points have to be considered. Grinding process should operate itself over a very long period of time, and material level with grinding mill should match the hardness, and material of uniform ground grade should be obtained. Various process parameters are monitored here. Here we include the parameters such as fresh feed rate, coarse return bucket, elevator loading, mill inlet and outlet pressure, mill levels, etc. And here the raw material, all equipments are programmed by PLC as well as backup control deck. Required operations are programmed by ladder rung from starting to stopping, and sequential control is done by PLC. And the object is to achieve maximum output of production with required composition and fineness. And next will be continued by Kishore.
Okay. Kishore can take over. Soumya, you can turn off your video. Kishore, you have to turn on your video. Kishore is here. Unmute yourself.
Okay, ma'am.
Ah, okay.
Hello.
Unmute yourself.
Hello.
You are audible. You can continue. Slides. You can see the slides.
Okay, ma'am. Okay, ma'am.
Ah.
Good afternoon to everyone. I am today discuss about the cement kiln control. Kiln is the heart of the cement plant. The word kiln was originally pronounced kill with the n silent. The kiln thermally insulated chamber. It is a type of oven. That produces the temperature sufficient to complete the some process such as hardening, drying, or chemical changes in the cement plant. So it has to be controlled properly for a good quality of clinker and for smooth operation of the plant. You can see in the first diagram kiln. This is the kiln in the cement plant. Clinker are the small cement raw material. Clinker is a solid material that produce in the manufacture of Portland cement of a intermediate product. Portland cement is the brand of the cement. Next slide, ma'am. Okay. Optimization of kiln. Optimization of kiln is very complex because optimization in fuel consumption, clinker quality, and production cost, etc., are to be optimized. That is done by the microcomputers. Next is the optimization control of rotary kiln. Oxygen and CO content, temperature burning zone, exit gas temperature, secondary air temperature, optimal control of burning process, etc., are the optimized control optimization in the rotary kiln. Next. Input data parameters. These are the input data parameters are to be controlled. Kiln speed, fuel feed rate, raw material intake in the cement plant, glass flow rate, etc., are controlled by the computer. Next is the clinker cooling section control. Controlling the clinker cooling by increasing the cooler efficiency is done by keeping the secondary air constant and controlling the flow of secondary air, and also control the temperature of the secondary air. Next one is the kiln speed control. The computer controls the basis of set point, and small variation in the set point are controlled by computer automatically. In case more disturbance occur in the set point, dash cause the kiln upset. Then they intermediate and control until it stabilizes. Next, man. Next slide, man. Fuel feed rate control. The fuel feed rate control is indirectly related to the sintering zone that is measured by partial radiation pyrometer, total radiation pyrometer, optical pyrometer, and two color radiation pyrometer. Readings of first three are affected by the kiln environment, and with the help of two color radiation pyrometer, the computer can accurately control the fuel feed rate and keep the burning zone temperature in the desired limit. Next one is the stabilized control of kiln. Here, back-end control is necessary. Means monitoring of O2 and CO in the exist gas and exist gas temperature for controlling O2 and CO is done by increasing and decreasing the fan motor speed of oxygen and CO with specified limit. And the exit gas temperature is sensed by thermocouples that are directly controlled by the computer, and they are automatic. From this, material handling equipment can operate without damage. This all about the cement plant operation, madam. Thank you.
Okay, over.
Okay, ma'am.
Okay, I'll stop sharing the screen. Okay, you can turn off your video. Others, do you have any questions for these two batches? Other students, other than these two batches? Or even the first batch can ask question to the second and second batch can ask questions to the first? Or anybody from the class? Any questions for these two batches? Have to reply. No questions? Yes, Sakshi wants to ask something. Am I audible? Am I audible?
Yes, ma'am.
Okay, any questions?
No, ma'am.
Okay. So I appreciate both the batches. The first batch, your presentation was well organized. The slides were good. For the second batch, you have collected extensive material. The presentation of three of you was good. Pawan was reading the slides, but anyhow, he managed to complete his part. So I appreciate him also. Since this is the first experiment, I congratulate all of you for doing it successfully. For remaining three batches, three more batches are remaining. I will schedule the presentation for tomorrow. Tomorrow, maybe in the evening, I'm going to schedule the presentation and I'll send you the link of the meeting. Okay. Is it okay for everybody? Tomorrow, all the three batches have to present, remaining three batches. Or any batch is having any problem? Any batch has any problem? Since you have already sent your PPTs, I have those PPTs. We will do it in the same way as we have done it today. Will it be okay?
Yes, ma'am.
Okay. So tomorrow I will not at 3 o'clock, maybe after 4:30. So tomorrow evening I am going to schedule the meeting. Morning I have class for 6 semester, so morning it is difficult for me. In the evening I will schedule the meeting and I will send you the link. Is it okay for all?
Okay, ma'am.
Okay, ma'am.
Okay. So now I will close the meeting. We will once again meet tomorrow.